I'm going to repeat a little bit some stuff. So I'm technical evangelist for AWS, based in Nordics. I came here to do some talk about AI in particular, and I'm loving it here. It's warm. It's something that I'm not used to. It's so wonderful. This talk is really more specific towards AWS Rekognition, which is one of the high-level AI services that we have. How many of you were in the first AI on AWS? So I get the cool. So I'm not going to go through too much of the generic. But what I can say quickly is recognition and in general image understanding is super important at AWS and Amazon in general. You can imagine all the kind of services that we have from actually the Amazon.com website, which we received a lot of product images every day that we need to analyze, identify what's in the image. Is it relevant to the category of what is being used? The Amazon Go to understand what's actually happening in the store right now, inventory or things like this. 2 drones that take images as well, understand how they progress inside their journey to the last mile delivery, all this kind of stuff. Recognition and image analysis is extremely used inside AWS. So it was very natural for us to offer this as a service for our customer. And in fact, it was one of the most demanded service from our customer before we launched it. So this is a service that was launched last year at re:Invent. So re:Invent is our very large conference, customer conference that we held in Las Vegas last year, and it was announced inside our AI services. So this is the entire AI ecosystem, and today really I'm going to concentrate on that one in particular, which is Amazon Rekognition. And no, it's not a mistake, we really have a K in there. So because I'm going to talk a little bit about neural network, quickly, I know I've been talking about this, but neural networks is very simple. It's a bunch of neurons that take an input, weighted input in fact, and then produce an output. And in every neural network, there's a training, and you train your neural network to obtain the best possible result. And the fact that you can use backpropagation to actually alter every input of your neuron to create the best possible neural network is what made neural network very good. And they're actually very good at doing what humans are doing, analyzing images, doing text, or kind of simple tasks like that. And we're talking about deep neural network, in fact, when there is a lot of different layers, right? And especially for image recognition, those layers can represent a lot of things. They can represent what we call feature maps. They can be regions inside the picture where there is very high quantity of activities. They can be high contrast. They can do all kind of stuff. In fact, the neural networks extract their own features, which are then used to be able to recognize what is being given to that neural network. For image recognition in particular, one neural network that is used is convolutional neural network. The thing what it uses in convolution to be able to calculate those feature maps. And at the end, you have a connected layers that actually gives you the result. It goes like this. You give it an image, and it returns you a set of labels that then you can assign to that particular image. So this is really a high level how image kind of deep networks work for image recognition in general. And you can imagine a very large neural network, up to thousands of layers, can extract a lot of different features. The more layers, the more accurate your neural network will be. And the more particular, you can train it to recognize very funny things. And I will going to show you some demos a little bit as well. Something particular as well about deep learning, especially neural networks, and in that case, image neural network, is that they need to be trained. So there's what we call the ground truth generation, in which we actually use very large sets of data sets to train that particular neural network to be able to recognize general images. That involves humans that annotate images, and then we feed this into our model, train that, and then we train the model, get the model, and then use that to actually create the service. So it's something that you don't have to do yourself. The training part of neural network is what takes most of the energy. Training requires a lot of GPUs, and you can imagine a model that has thousands and thousands of layers is something that you need enormous amount of GPU. So really cloud computing is really the sweet spot for doing everything neural network modeling in particular. So that's why in the last maybe 4-5 years it has become very, very popular. And in fact, the trend in having deep neural networks is really matching with the advance of the cloud computing. You already questioned, I love it. Woo. So you mean a hidden layer? Not in particular. It depends how your neural network and which algorithm is structured, right? But you can express a feature map with a set of layers. So you need to actually pass through a bunch of layers to extract the particular feature maps. And in fact, one will feed the other. So very, very often you see, for example, if I go back from this image, in that sense, yes, right? But it will extract features that can be represented, in fact, to connect the neural network. So in that case, for example, you see, you start with an image, and you can extract. In that case, it's highlight in the image that I use at the beginning, and then pass, and then you can extract from each layer. You can extract the next feature, and in fact, you end up at the end with something which is called the feature map, which is a set of all the layers that you can link together to have a representation. In that case, is a dog. So here you would end up from here, feed back up like this, and that to represent this dog. And it has to go through one path in your neural network, and this is what's called the feature map. Right? Yes.
Tell me if it's too early to ask.
It's never too early.
No, I mean the lecture.
Okay.
Can you constrain the search space to, let's say, only dogs?
So Rekognition is very high-level service. It's a
Can you repeat the question?
Oh, sorry. So the question was if we can train currently Rekognition to recognize particular things that you want. Is that correct?
Yeah, like dogs and all
You-
the subdogs.
Right. So Rekognition is a general purpose service that is offered by Amazon. You don't have to do anything to it. You just feed it a picture, and it will return you the labels. And this is what I'm going to explain. I'm talking now about the general purpose of how image recognition deep learning algorithm work. Rekognition is a service that is super high level. You have nothing to do. If you want to train it yourself, you need to go a bit lower in the stack to do it yourself. So deploy a deep learning AMI, for example, and then train your own network. MXNet, for example, is very good at doing that. There's a talk just after me on MXNet where they're going to do a demo about a particular image recognition for numbers, for example, how you can train it. Yes?
If there's multiple objects in an image, what will it do? Will it
Well, let's
only
check it out. We'll do a demo about that. We'll return all the labels that are there, right? Yeah, of course.
as 4 different parts of the picture?
We are returning labels that we see in the picture. We don't return the location of those labels currently, right? Gotcha?
Yeah, well, I thought from your slide earlier that you return a list of labels of...
You mean this one? So this is not about recognition. This is the general deep learning process for image recognition in general, how our algorithms are built. So Rekognition is a service that is built on top of MXNet, right? We don't give you anything to train. It's really, we've trained the model ourselves. It's a general purpose so that it's made very easy for you as a business, as a startup to use, or any other big company that just don't have the resource to create their own model, right? So this is actually a service that allows you to do object and scene detection, facial analysis, facial comparison as well. It does also celebrity recognition, so if you can train it to recognize, or it's trained to recognize thousands of celebrity. And you can use it also for image moderation, and we'll go a little bit through that. The first one, which is the classic, is object and scene detection. So this is exactly this. What you refer, you can give it a picture, and it will return all the labels that it sees in the picture with the confidence index of it. In that case, it's an image of a city, right? So the image, and the image is not that simple. In fact, there's reflection that makes it quite difficult for standard AI service, like for image recognition services, to detect its city. But this is pretty clear here. It's a city, downtown, and all this kind of stuff. How it works is you send the photos through the API, and then it returns a JSON object. All right? So let me show you quickly what that means on the. Okay. Oops. Let's go there. So everyone sees that, right? Yeah. So this is an image of me in Iceland. There's a lot of filters applied to it. Don't look at that. I'm an Instagram freak. But basically, this is the image I want to index. I have lots of images. Every time I travel, every time I do a talk, I try to visit a little bit. So I end up with enormous amount of pictures. And for me, it's very important to be able to search them. So I threw them everything to Rekognition. And what you can do is really run a simple script to do things like this. So in that case, you would do Rekognition. And what you can do here. This is the detect label API. So it's super simple. It's one line. You call the service. Here, what I'm doing is I'm doing a reference actually to the image, which is stored as an S3 object. So I've put all my images into S3. Luckily, I don't pay for it. It's not expensive anyway. But so don't tell my boss. He's not here. Oh, damn it! So I use S3 bucket for that. That's my last talk, probably, so I'm going to take the most of it. I'm open for jobs after that. Thanks. So I put the image into a S3 bucket, and so I want to do a detection. So it works like this. Officially, it works if I'm connected to the network. So you see it returns a JSON object with a set of labels. And here, luckily, I look human enough as well. But you see, it also detects a horse, right? So, and these are the confidence index for all those. Yes?
Do you have like higher level classifications for these?
So you're talking about ontological references. No, in fact, this is really just returning your labels. But people can use ontologies to refer to the high level of a kind of.
These are labels that you're building into the platform. These are labels that are defined.
They are built into the platform. I didn't have to do anything. I'm just using the service as is, right?
So where's that higher level of knowledge being built?
In our services, right?
So we know it detected that there is one human and one horse.
Absolutely.
We don't know which is which.
Correct. Correct. And there's another API for that. So now that's a very good question. So very often you would first detect if there's a human in there, and then you can use that API and instead of. So here, sorry. Sorry. Get more going clear. So I detect my labels there, right? And then what I want to do. Oops. Let me. Whoops. What I want to do is now I know there was a face there, so I use the face API with attributes all to actually really understand what's happening there. And there you see I actually get the bounding box for my face, right? So it's just I use the detect faces there, right? So very often you build a service like this with general, you want to detect the labels, and then if you see a human, then you want to have more details into the human. And this is just two API calls. And then in this, you see I put attributes all. So that means it also returns a set of emotions associated with me there. And I do look happy because I was really happy there. So I look confused 1%, which is great.
Again,
It will return the bounding box for every faces, ICs, and the features. Yeah. You see also it returns the XYs of each features of the face. Right? So you can then do tricks on it, use those coordinates to actually use OpenCV and then put stuff on it. So let's go back into the presentation. What just happened there? You don't see, right? I see it on my presentation. What? Come on, F1. Save me. I don't do anything right now, so something is happening. It's good? Yeah, cool. So you do things like this, right? So it's an API that returns a bunch of labels. The second API is what I just demoed is the facial analysis, in that case with all the attributes. This is exactly for returning this set of things, what you want to know, whether there's glasses, a beard, a mustache. For some reason, knowing that there's a mustache in someone's picture was very important for our customers, which I understand.
Will you get Wonder Woman or Gal?
Huh? We'll do the test, I guess. Do you want to do the test right now? Let's do it. Let's do that. Where is my console? There. So let's do a facial analysis. There. Where is on my desktop, I guess. That's Wonder Woman. So this is a facial analysis, so it's not returning names of people. It just returns how old she is. I'm sorry if she's here and it's not right. But if you want to know the name of that person, you would use the celebrity recognition. You see. So here, let's do that. And that's a live demo. I hope it works, and it does. So it does. It does recognize Gal. So this is really how simple it is to use, right? And it's just 2 APIs. So if you return, if you know it's a person and you want to test against a celebrity, then you can do that. Bear in mind that you, let me go back into my talk. I'm gonna have problem with that. Oops. That's cool. There's no notes, by the way. You see? Seriously? Swap display. It is. All right, cool. All right, so this is the API. Also returning a JSON. What you can do is also face comparison. If you give it 2 pictures, it will be able to recognize similarities between pictures within those. What it does, it returns the bounding box also of each picture with the similarity index. Right? So you can really do cool stuff with OpenCV on top of that. The celebrity, we just did it, so it was a very good question. Yes?
Ask if an image or a face is a member of a group of faces, or just
So it will compare 1-to-1 with by giving you also each bounding box which it's referring in the comparison. One of the things we just launched also a couple of days ago is called image moderation, which gives you an explicit value of that image, whether it's nuditive or suggestive, if it's wearing a swimming suit or if naked, all this kind of stuff. So this is very important for customers, obviously, that do that indexes images of customers or that use images for improving their services, and they don't want customers or their own customers to upload nudity pictures to appear online. I'll show you one case after that. Again, it's an API return a JSON object, very simple with a confidence index and the value of that subjective moderation label. There's a lot of actions that are supported. These are all APIs, so an action represents also an API. So you can compare faces. One thing that is very interesting is you can create collections. So if like me, you are not a celebrity, you can create your own collection and label yourself as a person inside your collection, and then feed it another image, and it will recognize that person automatically. So you can create your own collections where you run your own images and celebrities, your friends, and things like this. You can, of course, manage this collection, delete all this kind of stuff. You can list your collection, which is very important as well. You can search faces within that collection as well. So if you have a collection of thousands of images, give it another image and it will return the images associated with that. Yeah. Yeah, only images. Yeah. Yes, question? So the question was if this is industrial or recreational. It depends what you mean by industrial. There's very, very large companies using this, like globally, C-SPAN being one of them. But in factory, it depends. You have to test. I don't know, to be honest. If it's something you want to train your network to do specific things, this is where MXNet is to the rescue. You just feed it a bunch of data that is specific to what you want to recognize, and it will be specialized in that action. Yeah. Yes. Good question. So when you call an API, the question was, does it have to be on S3 or can I give it an URL? You can put it on S3, but you can also stream the image directly from your API. So if I would have my image locally, I can push it directly there. You cannot give it a URL as a reference, and then the service would download it from there. Simply for safety reason, we don't know what kind of URL will give you. Right. All right, cool. I can take questions a bit later, so I have time to go through some demos. I talked about this already, collections, where you can then search by face, and it will return you the similarities in your collection. It's using the nearest neighbor algorithm, right, to search. The pricing is interesting. In fact, you can start for free for 5,000 images per month for the first 12 months if you want to test it. So if you want to test it in an industrial environment, I invite you just to try the feature. You can do that. If you go really heavy on it, a million image processed per month, you are still at $1 per 1,000 images. So I think there's places for testing that. But again, if you really have something particular, I would suggest use MXNet with that particular case that you want. This is again a general purpose image recognizing service, image recognition service. Let's do some tests. How many of you have been following a little bit Twitter in the last, let's say, month regarding image analysis services? Not many. So there's been a big debate whether image recognition can recognize sheepdogs or mops. So to be honest, I didn't even know that dog existed before. That's just fantastic. And if you go, in fact, if you go on Twitter or on YouTube and you put those, there's a lot of people doing fun videos on, is this, having the shepherd just sleep there and people think it's him up and all of a sudden it comes alive, all this kind of stuff. So it's very difficult, and it's actually a genuine problem, right, for image recognition services. How do they differentiate? And the quality of that really depends on how big your neural network. And we're going to test. I took a bunch of those photos. We're going to test live, see how it goes. Another fun thing is and this is super funny in my opinion. But my girlfriend had a Chihuahua, and I never thought it looked like a muffin before I thought that particular tweet. And it actually does look like a muffin. And again, it's something that we can test together. Is it a bagel or a puppy? Right? How many of you have seen the puppies there first? This is incredible. In fact, there's puppies all over the place. Right? 1, 2, 3, 4, 5, 6, 7. They really do look like bagels to me. Is it a labradoodle or fried chicken? You get my point, right? It's super difficult to if you would do your own, right? Think about it, how much images or how much data you would need to use for that. So let's test all that stuff live. Oh yeah, and there's this marshmallow and Shiba. I think that's it's a husky that looks a little bit like a marshmallow. Especially people love to take the face of it, make it like a marshmallow. What is very interesting, I think, in those images is you see the colors are the same. So if you go really fast, as a human, if you would go fast, you can easily make mistakes. And I think Guy was here. We'll talk about MXNet probably how good it is compared to humans at some point nowadays, right? Better than human nowadays, yeah, exactly. So let's do some testing. Well, where's my console? Let's go there. So let's go into object detection. I'll go there. Sorry about that. Cool. Let's start with, let's do some bagels. So I have a bagel here. What is that? It is a bagel. No confusion there. How about that one? That's again view from the top. So again, it can be, oh, that's pretty good. The image are not really good quality here. So let's give it a puppy. This is actually quite, I thought was quite interesting, this one. Because if you look from far away, in fact, it's very difficult to know it is. But this is, I was even surprised by that result, to be honest. Let's do that one. Where is my puppy picture? I used to have some baby. Let's go to these ones. The mop. I think that's the most funny one. Let's give it this one. What is that? Right. So you can understand this. We recognize the food. We recognize broom and shorts, but unfortunately we didn't see that. It's very complicated. How about that? Accessory. Yeah. Let's try that one. All right, cool. Yeah. Yeah, this is pretty good result, 60% actually, yeah. Yeah, but look at that, for example. Would you know, really, it's a dog? This doesn't. So this is an image actually that you found on YouTube as well. So let's try those ones. The marshmallow. Oh, actually, also this is very interesting. What is that? It's an animal. It's a dog. This pretty good there. It's quite confusing if you look about it. This is the funny one that looks like a marshmallow, and it recognizes very well. Let's think about this garlic, or a garlic or mushroom plant. Oh, cool. Let's see. We have. This is quite cute. It's good. Nice. So yeah, you get the picture. It's not, it's not easy to do that at scale. Let's look the dog and pool. As well, this is something which is quite difficult because there's a lot of reflection, and it's from the from under. So I think it's fair to say that it's doing very, very well there. All right. So then let's go back to the presentation. Again, it's just terrible, this stuff. You got it? Yeah. All right. So once you have a service that can do recognition, there's lots of stuff you can do, and this is how customers are using it. So the first is really making a searchable image library. Very typical case is you would send an image into S3, and then you create an action to get that image, label it, put the result into Elasticsearch so that you can actually start searching on those results. This is the most common use case for using recognition. Second is to do image moderation. So as a user would upload a photo into S3, you use a Lambda function to check recognition, see if there is nudity in that picture, and then you can approval process, automated or a human to it to accept the image to be uploaded. Right. This is very used as well. Second one, the third one is to do some face verification. So if you want this is I put it here, but don't use it as the only mean for security, right? It has to be in the process of using some third MFA or something else, right? But it can be used to authenticate or to recognize people. So your application could use recognition to see if that's the right person, and then send an SMS to also have a second verification. But this is being used nowadays already in a mobile device to see if you are the one, the right one. Sentiment analysis. So this is used heavily in shops to track users, to track customers in front of particular product and see what's the facial reaction. And then a customer can adjust the advertisement or the placement of the product based on that sentiment and see the journey of a customer through a shop. Where is he happy? Where is he confused? Where all this kind of stuff. So this is used a lot for optimizing customer experience inside shops. Yeah, so I talked about recognition to, and you can do also if you have very large collections and you want to do image recognition inside those big collection, you can use AWS Batch, which is going to take all those images in your S3 bucket and parallelize the process of doing this index. In fact, this is the architecture that was used by C-SPAN to index their whole collection of media information. Something which also we've wrote a blog post about it quite recently is for recognizing a person of interest inside the cities, right? So the state of the Washington County Sheriff Office has used recognition inside to help officers and to help the police to actually recognize people. Right, so they have a very large database of people that are of interest for them and to track, and then they allow their police officers to take a photo of person and match them across a very, very large set of people that they are of interest for them. And what they believe is actually it's going to be used, it should be and will be used widely across law enforcement in the future. There's a lot of customers that are using recognition. In fact, every time I have a talk, I've then received an email from customers that start using it. And I mean, C-SPAN is one of the classic use cases. What they've done is, you know, it's a media company that holds videos where politicians are in there. And they wanted to index the entire set of videos, what they had. So they extracted frames every 6 seconds from the entire video collection, and then matched them against their known individuals, right? And they have currently 97,000 known individuals in their collection. They've in fact moved the entire or indexed the entire data set in a couple of hours, and we're talking a lot of terabytes of data. Another company using recognition is Influicity, which does marketing, or it's a marketing service for their own customers, and they use recognition to enhance the service, so make their customer have marketing strategies and improve the marketing inside there. Shadi is using recognition for image moderation. So Shadi is the Tinder of India. What they do is they want to match people, but they don't want people to put nudity pictures there, obviously. It had become a problem, in fact, in their services, and they started using recognition to ban and remove all those pictures. And they also use recognition at the beginning when people register to check every photos that it's not bad. And I talked with the CTO a few weeks ago, and he said that it was a lifesaver for them for their service because they didn't have the resources to buy to build their own models, so they could just start using it very fast when it started to become a problem. let's do a demo. Very interesting thing is those services are so easy to integrate, right? And I'm a developer background. I love hacking things together. So I had to build an application and see what we could do with it. So I'm inviting you, if you have a phone, go on this address, the polyco-add-on.me. And this is a service that is powered by Rekognition and Poly. Poly is text-to-speech synthesizers. So what it does is you can take a photo of you on your mobile phone, upload that to Rekognition, and it will tell you facial analysis of yourself or objects, what it sees. It starts with an object and scene detection. If it sees a human, it makes another API call to understand more about you as a human. It works like this. It's using 3 services, Cognito, which Ian talked a little bit before. Cognito is an authentication service. In that case, I'm using an authenticated API. So I just get a token to Cognito, and this token is associated with a set of services that you are allowed to use only in read-only mode, right? In that case, it's Rekognition and Poly. So anyone that is using that application is getting a token for Cognito, and then because of that token, can start detecting things with Rekognition and then get its speech with Poly. It's very simple to use. I'm just want to show you the code quickly. The code works like this. Whoop. So it's JavaScript, right? So this is a web page actually that you can hear people are already playing. It's a web page HTML index that I'm hosting on S3. It's very simple. I put that HTML page in S3, and it uses JavaScript to take the photos and upload it to Rekognition. You see here I'm getting the identity from Rekognition, right? And then I just call the Rekognition detect labels there. And then if I have an image there, it will try to detect faces, and it does that by calling Rekognition detect face SDK. This is a JavaScript SDK. Is really few lines of code. It's so easy to use, and it's now you have the HTML page. You can really download that HTML and AI. In fact, it's also in my GitHub, which is at Orn as well. So there's Polyco. If you want to download the entire code and the deployment scripts, automatic is everything there. Another demo that is very, very nice is creating your own media indexer. So I'm going to show you that as well. Something which is also available. Where is my? There. So here it's a local backend running in Node. And what it does is create you a browser in which you can upload the photo. It's calling Rekognition and then just creating like a media library. So let's do that. What it does is really simple like this, and then I can upload my photo. And this is a very typical case of how customers are actually using Rekognition nowadays. They have very, very large media libraries, and they want a very simple, fast way to index what they have there. So this demo in particular uses step functions that I've shown, and you can then get your photo automatically tagged like this. So you can imagine photographs and websites that are using for photographs are jumping on that because it's very simple to use. How much time do I have? Because I don't have time in front of me. What time is it supposed to end, this one? Now. Awesome. And actually, this is the end. All done. Let me show you that. Cool. Thank you. And if you have questions, don't hesitate to contact me on Twitter or my @orn@amazon.com, stuff like this. Happy to help.